Hey guys, Ben from Toolbox Buzz here, and I want to do a review on the Vinnic PS700W mobile charging station. So I just got this in the mail a few weeks ago. The timing's been good here on Cape Cod. We've had a bunch of storms, we lost power, and so I've really been able to put this through the paces to figure out what are some of the strengths and also some of the weaknesses and give you that honest review that Toolbox Buzz is known for. So if we can, we'll take a peek at this real quick and just go over the basic setup here. Okay, so this is a 110 volt US style or US adaptable mobile power charging station. And I think that's important to note, as we'll get into in a little bit, that this is really more of a charging station than it is a portable generator, which is what Vinnic will say on their website and not something that I'm fully on board with. If we take a peek at the overall unit, it weighs just over 13 pounds. It does have an aluminum metal case, built-in carrying handle, both a solar as well as a standard 110 volt DC plug-in charging port in the back, integrated fan, and then you see the front. So it has a total of 10 different adapters or 10 different plug-ins on the front. We fire it up by turning on the power switch. Then we activate the AC or the DC because it does have an internal converter, and we just do that by hitting the buttons on the front. Okay, it'll tell us the current charge level and then the current wattage output, as well as the time from when we've most recently turned it on as it's drawing that power. I've got 4 USB-A ports. I've got 1 Type-C port, 2 AC 110 volts, and then we have the 12 volt cigarette plug-in in the front. Okay, for a total of 10 with those 2 DC outputs. Okay, let's go to the whiteboard for a second because I want to talk through some of the math, because I've seen some of the other reviews on this and I don't want to oversell what this is. This is a 512 watt hour or 700 continuous watt system. So I think it's important just to look at the math real quick, okay? For those who aren't following, I just threw it out on the whiteboard. For anybody that knows me, they know I love whiteboards. So the basic math is watts equals amps times volts. This is a 700 watt continuous system at whatever amps we're going to draw from it. And in this case, I'm going to use the 110 volt plug because that was what I was using it mostly for out in the shop. I never had an issue if I was plugging in a USB or a Type-C. The highest power draw of anything I plugged in was easily coming from the 110 volt. Okay, so if we flip the math, that becomes 700 divided by 110 or 6.36 amps. So this math tells me that I can continuously run a tool that's drawing less than 6.36 amps from this unit at a time. Now what I found, and what I'll show you here in a second, I'll put in some video clips, is I was able to run a 5 or 6 amp angle grinder, no problem, but when I went to a shop vac and tried to run that, it was giving me an overcharged signal, which is what I've seen other users experiencing as well. So I'm going to cut to that clip. You'll get to see what that looks like. It ran the angle grinder no problem. I just showed you the video of that, but I want to show you what happens when I plug in my standard shop vac. Okay, so stand by for one. All right, so I'm going to go ahead and turn on the AC. Okay. Let's go ahead and fire it up. All right, so it ramps up to 100 watts, and this is a 500 watt unit, and then I get this overload signal. That's why I say, as we come back over here to the tool, that this is really more of a mobile charging station with an ability to run some lighter duty tools. This is not a tool that I'm going to bring on a job site and expect that I'm going to be running a higher draw tool off of, right? I'm not going to be running an 11 amp table saw. It's just not going to happen. But if I wanted to bring it to charge batteries, which have a lower amperage draw and more of a trickle charge, that's where its strength lies. And so it absolutely has a place in the workshop. I think it's just recognizing the strengths and weaknesses of what it brings to the table. So just to kind of see where we were at, I plugged in 2 of the Ryobi 40 volt batteries on a dual charger, pulling at the same time, as well as one of the DeWalt FlexVolt 2060 volt batteries. I was pulling, of the 700 average watts, about 145 watts of power, and that was going to run through the battery in approximately 4 hours. So you're looking at about a 3.5 hour charge time from 0, and then depending on the draw that you're pulling from the system, anywhere from a 3 to a 6 hour or longer battery life to this. So let's talk about some of the design features if we were to take this apart. Okay, so first of all, the internal inverter is separately stored from the battery compartment. The batteries would actually be kind of on the bottom half with the electronics and the inverter up in the top half, which is a nice thing because that means that the heat dissipation is going to be happening in 2 separate areas, and it's going to be much harder for this unit to overheat. So that's one thing that's pretty nice. Another nice feature that they've got is right here is where the exhaust fan is at, and it's an intelligent fan, right? It's hooked into a thermostat, and it will kick on at approximately 95 degrees to keep the internal temperature from going over that. This battery can run from 0 to 40 degrees Celsius, meaning about 32 to 145 degrees Fahrenheit is the range that it'll operate at. So it's a pretty good range. But it will operate, again, a little bit of conflicting messaging on Vinnic's site. It says it'll operate down to -4 degrees external temperature outside. So I've had it out in the workshop at about 20-25 degrees, and it's been working fine for the last few weeks, which is lower than the 32 degrees, but not by a whole lot. So I appreciate that they've got the intelligent fan. I appreciate the way that they've got the electronics separated on the inside. Another feature that they've got is it's not just a standard lithium-ion battery, but it's actually a lithium iron phosphate battery, which is the same style of battery used in like a car battery, which means it has a longer lifespan of about 10 years. And depending on if you're charging at a 50 or an 80% cycle, anywhere from 4,000 to 8,000 battery charges. That's pretty good. That's pretty good longevity. So how much are you paying for such a setup? It depends, right? It always depends. But anywhere from $800 to $1,000 is where Vinnic has this currently priced at right now, as they're just getting ready to launch their campaign. So for me, that price point feels a little bit high based on not being able to run tools off the site, not, for this not being a true replacement for a gas generator on site. But it does have a place in the shop. I would use it on a job site if I needed to, again, be trickle charging some batteries or potentially running, lower amperage angle grinder on site, something like that. So overall, the design is pretty high quality. It feels very sturdy. It does perform well. I appreciate the LCD design and that I can see the draw, the amperage, and the current battery state. But hopefully this was helpful and truthful and straightforward. I'll go ahead and put the link so you can see the Kickstarter campaign site that Vinnic's got and see all of their materials that they have. But hey, there's my 2 cents. Appreciate you tuning in. Thanks very much. Take care.